Okay, so now this is our second sequence of reactions. You do have to be able to name each of the molecules if you're given the name of the molecule in your exam. So in this case right now, you're working with the primary alcohol, and then you want to convert it to a carboxylic acid, and then a carboxylic acid you want to convert it to ester. So what from this table right here, and what will be one that has the starting material of an alcohol? I'm looking at this one right here. You have the alcohol and you add PCC, but you get an aldehyde. So this is not an aldehyde. We want a carboxylic acid, so we cannot use PCC. So I'm looking here, and this is a secondary alcohol. That's not the one I want. We're looking at, oh, right here, we have another alcohol, right? A primary alcohol. If we either use potassium permanganate, we do get we do get the carboxylic acid. So this is the one we want. We want to use potassium permanganate to get a carboxylic acid. So when we go from a primary alcohol to carboxylic acid, that will be an oxidation reaction, right? Because you're adding more oxygens. Now, I want to get from a what? A carboxylic acid to this ester. So that will be an esterification reaction. So if you look at your table right here, you're starting off with the carboxylic acid, and then you have to add an alcohol. You see this R'(OH), and then you have an acid and heat, and you will get your ester plus water. Okay, this is really important. I did not add the water right here, but you should know that you do have your ester plus water. And for example, on the exam, you might be given a name of a carboxylic acid plus an alcohol. So if you have the carboxylic acid and then plus an alcohol plus an acid and heat, then you know that you're going to be doing an esterification reaction, and you're going to be left with an ester plus water. Okay, so what if we want to reverse the esterification reaction? So what if we want to go from here to here? So what's going to happen? We're going to have to split up. I added this image right here. We're going to have to split up this molecule. So if we do an esterification reaction, this will be the last one, okay? It's because you're starting with an ester. So we're starting off with an ester, and we want to go back to our what? Our carboxylic acid, but we will also have an alcohol because we're splitting this ester up. So this side right here will be our what? Our alcohol, right? Will be our methanol in this case, because you can have a longer carbon chain. You can have an ethanol or propanol or butanol, but in this case, this is we're keeping it simple. So right here you have a methanol. After you're splitting up this ester, you have a methanol, and then which is your alcohol right here, and then you will also have your butanoic acid back. Okay, so what's the name of this type of reaction? That will be what? When you're splitting something using water, that will be a hydrolysis reaction. So when you're going back from an ester to a carboxylic acid and the alcohol that you added to it, that will be a hydrolysis reaction. So this is really, really important because you will have questions on the exam that will ask you to react a carboxylic acid with an alcohol to get an ester, and then how do you go back from the ester to your carboxylic acid plus the alcohol that you added. Make sure that you know which side will be your alcohol and which side will be your carboxylic acid. So this is very obvious. You're splitting up this ester, right? So this side right here will be your alcohol, which is right here with the apostrophe. So that's why you have the R apostrophe right here. R apostrophe right here will be your alcohol. And then the side where you had the carbon oxygen double bond, this will be your carboxylic acid. That's it. It's right here. Okay. So the table will be on your final. So don't freak out. So just know you should be able to tell which side will be your alcohol and which side will be your carboxylic acid. Again, you're splitting them up. One side will be your alcohol, as you're looking at right here, the one with the little apostrophe right here. And the other side with the double bond, the carbon oxygen double bond, will be your carboxylic acid. So how can we reverse the esterification reaction? By doing hydrolysis, right? With water and acid and heat, you go back, you get your carboxylic acid back and your alcohol that you added, okay? So next question is, how can we go from carboxylic acid back to the primary alcohol? So how can we go from here back to here? So what do we need? Where is it? So it's not right here, but let me look at it's not right here, but because we only covered, oh, it's right here. I'm sorry. Oh my goodness, I should be the one studying this table that I made myself. Oh my goodness. I did make this table and I'm like forgetting where things are at. Okay, it's been a long semester. Okay, so we have your carboxylic acid right here as your starting material. You add lithium aluminum hydride and then you will get your primary alcohol. Okay, remember, and what is the name of this reaction? This will be reduction, right? So remember that for reduction reactions, you want to add hydrides, okay? But for our purposes, we work with lithium aluminum hydride and then these other hydrides that we have here. But you do need a hydride, okay, whenever you're trying to do a reduction reaction. So yeah, it's right here. Okay. So this concludes our overview of the final. Again, make sure that you do study all of the topics that we discussed here at the beginning of this video. Okay, I know you will do great. Remember to relax, study hard, and you should be okay. It was a pleasure to be your teacher this semester. You're all great people, you're all great students, and I wish you all the best in whatever your future on holds. So I'm very happy to have the opportunity to learn with you and from you, and I wish you the best for whatever it is to come in your life. And congratulations for finishing up this semester. All the best. Take care, everyone. Bye-bye.